what I want to finally do is an interesting aspect of, how should I say, of this sort of idea of random walks, because there is a difference between what we call a geometric random walk and an arithmetic random walk. So what you've seen here is effectively, we did the cumulative sum. So we summed up all those percentage returns. Yeah. Now, is this a valid thing to do? Can you just sum up percentage returns? Well, yes, you can. So what else would you do if you don't want to sum them up? Well, you could multiply them, right? So one thing is, you sum up a percentage return, right? And I want to show you the difference between summing it up and multiplying, right? So what we do is we just pick one of these random R's, which is already existing here. And let's get rid of this 100. So we just go cumulative sum R, and it just plots us some curve, right? Starting from 0 and then actually ending perfectly at 0 again. There we go. So, and then what we could do is we could actually do something different, and we multiply it. And so the difference between summing up and multiplying, you have to kind of understand it. And I explain it to you in financial terms, because this is what we're really about here. When you sum them up, just as you do percentage returns, it's basically like saying, for every trade or every day you invest the same amount of money, So you have a fixed amount of money, and then you add a certain percentage to it. And so let's say you invest $1,000, you make 1%. So what you're basically doing is you're taking your profits and you put $1,000 back there again. And then next day you do the same, and you invest and you take the $1,000 and so on. Yeah. When you multiply percentage returns, you end up with a cumulative profit. So your profit will actually increase. Okay. So the thing is, this example here is actually not a particularly nice example for what I'm trying to explain. So let's just do the multiplication. So we do plt.plot. And now we can, when we multiply them, we actually use something, the cumulative product. So it's just like the cumulative sum, but we use the cumulative product. So think about this. We've got our R's, and they're basically all kind of below 1. They're basically between -1 and +1. Right? So if you multiply like 0.3 times 0.1 times 0.2 and so on, what do you end up with over some time? Boom. It just doesn't, it does a little wiggle at the beginning, and then it just goes to 0. Because you multiply really small numbers with each other, and they just get really small. Like this is actually not totally 0, but it's like 10 to the minus 100 or something in the end, right? So it's technically 0.
Yeah.
Yeah. So obviously this doesn't work very well. It's like our multiplication. So the trick to do is to get this right is actually pretty simple. All we have to do is we have to add a 1 to this. Yeah. So because what happens is, now let's say we have 1% increase. Yeah. So it's 0.01. And then we have a 1% decrease, -0.01. So this will just, if you multiply this, it's going to be -0.0001, right? But if you add a 1, then suddenly you go 1.01 times 0.99, and then suddenly
the compound effect, right?
Yeah, it's actually like compounding percentages. Compounding interest is a similar thing. And then you can see here suddenly it's already giving us a better thing. But it still doesn't look great. Why is it not looking great? Because what happens is our random numbers are so volatile that even if we do this, if we add a 1, it still brings it to 0. And the markets are nowhere near as volatile. So what we can do is we can actually multiply this number by a relatively small value. So say 0.05. And then you can see they're almost the same. Now, we added a 1, right? And what we need to do really is at the end, we need to subtract the 1 again. Otherwise, and then these two curves are more or less aligned. Yeah. So this one is the compounded, and the other one is the non-compounded. Now, this doesn't really show the compounding effect very nicely. And so what I'm trying to show you here is basically simulating curves.